Hi there, and welcome to video number 34. This video is on error intervals. Now, this requires you to understand rounding quite well. If you don't understand the topic of rounding, please go back to some earlier videos that I've made on rounding to specific degrees of accuracy before you watch this one. Now, keywords are truncating, interval, inequality, limits of accuracy, and bounds. Now, truncating something is when you chop off some digits, right? You just chop them off and make the number less accurate. So numbers can be truncated as well as rounded. An interval is a difference. So we've got a small number, or the smallest number to the largest number. Okay, the difference between those, that's the interval. We refer to these as error intervals here. An inequality is a symbol that's used to show something is more than, less than, or more than or the same as, less than the same as. And limits of accuracy are the small number and the big number that the number that's been rounded could possibly be, and bounds basically means just the same thing as limits of accuracy. So the method that I've got for you written here is when a number is rounded to a given unit of accuracy, you must think half a unit smaller than the unit to get the lower bound. You must think half a unit bigger than the unit to get the upper bound of the calculation, and then of the number, sorry. And then these limits can be represented in what we refer to as an error interval, and that's with this x in the middle. And it's always going to have this less than or the same as symbol here, and it's always going to have this less than symbol here. Okay. Now, in number 1, the number 3.4 has been rounded to 1 decimal place. Someone has already done that. What are the upper and lower limits of accuracy? So it could have been 3.4 something, right? It could also have been 3.3 something. Okay. Let's have a look. So I always tend to just put the number in the middle, all right, like that, and then I just put a little arrow and a little arrow. You don't have to do it like this. There's my lower one, there's my upper one. All right, now 3.35, right? I thought of this number being 3.40, and then I thought of this number being 3.35. I thought of 5 either side of the number 40. That's how I do it in my head, all right? And hopefully that's how you'll do it in your head in future. 3. 3.45 would be the upper bound. Thought of 5 higher than the 40 to get the upper one. So I've got 3.35 and 3.45. Okay, there you go. Could be represented in an error interval, and that's what we're going to do in number 2 with these numbers. So the number 3465 has been rounded to 4 significant figures. That's why there are 4 figures there, and there were some numbers after it. What is the error interval for the number? Well, that would have been, and I haven't got really any room to write it down here, unfortunately, but that would have been point something. Okay, now let's think of 3.65, and then what was the highest it could have been? Well, 5, technically, 0.5, right? Well, that would round up to that number to a 6, wouldn't it? So we were allowed to put that there because of this inequality, right? And we can argue that 0.49 recurring does equal 5 anyway, but never mind that. Let's think about this inequality being used, and that's going to be 3.465.5. Okay, the numbers that are smaller than that, the lower bound of the calculation would be 3.464.5. Okay, because that 64.5 would round up to 65, and then that would disappear. Okay. So yes, a little bit tricky, this topic, but like I said, understanding rounding really helps. The number 2.4 has been truncated. It means it's been chopped off. All the digits after it have been chopped off. What's the error interval for this number? Now, it could have been 2.4. It could have just been 2.40. Could have been that, couldn't it? Right? Could have been 2.41, 2.42, 2.43, anything up to 2.5. Right, and again, because of the use of this inequality, it's going to read as, we could start at 2.4 as our smallest, our lower bound, and we could go all the way up to 2.5, or anything just under 2.5. So that's why we use this symbol without the line underneath it, because we're saying it's less than 2.5. Okay, so 2.4 is less than or the same as the number is less than 2.5. That's how that error interval reads. Right, moving myself over here. Okay. Mr. Bear has rounded the height of his son to 85 centimetres to the nearest 5 centimetres. What's the maximum possible height his son could be? So this one is a little trickier. Think of half of that unit. That's 2.5. All right, so we're thinking 2.5 either side of 85 centimeters, 2.5 centimeters either side of 85 centimeters. So my lower one, my upper one, and I'm just going to do both. I tend to do both anyway for any calculations. I don't know why. Just it only wants the maximum one, but the lowest one could have been 84. Sorry, we're going 5 centimeters. It could have been 82.5, and the upper one could have been 87.5. Okay, so the upper one, the maximum possible height that my son could be, if I'm Mr. Bear, which I kind of am, because it's my maths channel, we're gonna put 87.5. Okay, that's the maximum possible height his son could be. And then I've popped in there, what is the error interval for the height of his son? Well, that's why I did this here. I got the 82.5. So let's fit it in here. 82.5 is less than or the same as the height of the sun. Just pop in x, which is less than 87.5. Okay, so hopefully you've learned something from watching that video. If you have, please give it a like. Make the comments nice and pleasant and things that I can understand. Quite old, I don't understand some of the language that people use on YouTube. But thank you very much for subscribing, those that have. I refer to them as the Bear Cubs. Keep watching, keep practicing, keep getting better. There'll be more of these videos and there'll be lots of resources for you to use at some point too. If you're watching it and you're thinking, well, it's already there, well then I've already made it, haven't I? All right, but I haven't done it yet. I'm in the process of it, which is why I'm saying it. Now I'm just talking nonsense. Stop watching the video. It's finished. Have a nice day.